free falling. What is a free falling? A free falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in state of free fall. Two important motion characteristics that are true of free falling. Number 1. Free falling objects do not encounter air resistance, and all free falling objects accelerate downwards at a rate of 9.8 ms, or the rate of gravity. But Galileo Galilei is the first to suspect that regardless of the mass, fell at the same rate of acceleration, and showed that acceleration is independent of mass. Examples are fruit falling from a tree, a ball thrown upwards, and other objects that are dropped from a height. These are the kinematic equations that can be used in solving free-falling bodies. Number 1. D is equals to Vi times T plus 1/2 times A times T squared. Number 2 is Vf squared is equals to Vi squared plus 2 times A times D. Third, Vf is equals to Vi plus A times T. And lastly, D is equals to Vi plus Vf over 2 times T. And here are the other example problems.
Problem number 1. A construction worker accidentally drops a bricks from a high scaffold. A. What is the velocity of the brick after 4 seconds? B. How far does the brick fall during this time? Solution for letter A. First, let upward be the positive direction. Then, use the formula final velocity equals initial velocity plus gravity times time, where gravity is equal to negative 9.8 meter per second squared. Then, substitute the given to the formula, and you will get final velocity equals to 0.0 meter per second plus negative 9.8 meter per second squared times 4 seconds. And it will equals to negative 39 meter per second. So the final answer will be 39 meter per second downward. The next one is the solution for letter B. We have to use the formula x is equal to initial velocity plus 1 over 2 multiplied by gravity multiplied by time raised to 2. Then we have to substitute the value, and we will get 0 plus 1/2 multiplied by negative 9.8 meter per second squared multiplied by 4 seconds squared, and it will equals to negative 78 meter. So it's safe to say that the bricks falls at 78 meter.
Problem number 2. A tennis ball is thrown straight up with an initial speed of 22.5 meter per second. It is caught at the same distance above the ground. We need to find how high does the ball rise and how long does the ball remain in the air. Hint: the time it takes the ball to rise equals the time it takes to fall. Let's identify first the given. We have 22.5 meter per second as our initial velocity, and since the object is in motion, it decelerates and stops. That brings 0 final velocity. Also, we have an acceleration that equals to the value of a gravity, 9.8 meter per second squared. We use the formula final velocity squared is equals to initial velocity squared plus 2 times the acceleration times the distance. Since our final velocity is 0, we will only have initial velocity squared is equals to 2 times the gravity times the distance as our formula in this problem. To find x, or the distance, we derive our formula into x is equals to initial velocity squared over 2 times the gravity. Let's now substitute our given in the equation. We have x is equal to 22.5 meter per second quantity squared over 2 multiplied by 9.8 meter per second squared. And we will get 26 meter as our distance. After we get the distance, we will solve now the time of ball when it rises. We have a formula of final velocity is equals to initial velocity plus the acceleration multiplied by the time. To simplify it, we will get initial velocity is equals to the gravity multiplied by the time. As we said earlier, our final velocity is still 0 because it is a moving object. The value of our acceleration is equal to the value of the gravity, which is 9.8 meter per second squared. For the initial velocity, we have 22.5 meter per second. We derive our formula to solve the time of the ball when it rises, and it gives time is equal to initial velocity over the gravity. Let's now substitute our given in the derived formula. T is equals to 22.5 meter per second is equals to 9.8 meter per second squared, and that gives time is equals to 2.3 seconds. The fall time is equals to the rise time, so the time to remain is time in air is equals to 2 multiplied in time in rise. So 2 multiplied by 2.3 seconds is equals to 4.6 seconds. To conclude this problem, the ball rises at 26 meter high and it remains at 4.6 seconds long